Challenge activity 5.2.2, Excel hypothesis test for a population mean. All right, so we are still looking at, now we're going to look into actually doing the hypothesis test in Excel. So you need to click this link to download the spreadsheet. And one thing that's going to be important for you to see is that there's several sheets and tabs here. So make sure you're on the right one that your instructions tell you to, because it generates differently for each person. A school administrator believes the mean class GPAs for a given course are higher than the preferred mean of 2.75 at a significance level of 0.05 and checks a randomly chosen sample of 50 classes. Use sheet 2 of the Excel file to create a histogram and calculate X bar, the test statistic, and p-value. So this tells me sheet 2. Again, be real careful with whichever sheet you're on. So here's my sheet 2, and here's a list of 50 GPAs. So the first thing we need to do is look at a histogram. Now, some of you will have the histogram option right here under charts. I do not. So what I need to do is go to the data analysis tool pack, and I'm going to scroll up to histogram. Click OK. Make sure you select. So I already had this selected here. Make sure you select this entire column worth of, not the entire column, but the all 50. One thing that's also important is it's not automatically checked, is that you need to check chart output. Otherwise, it'll just give you a table with the bin labels and it won't give you the chart. And then you need to select whichever cell you want the results in. Click OK. Gives you this nice little chart that looks minuscule and hard to read. Again, this one has like a vaguely normal shape. It's not perfect. And again, that could have to do with some of the bin lengths. It looks slightly skewed. But let's go ahead and say that it is normal just for the sake of this argument, because it does have a very generally overall normal shape. All right, the next thing we need to do is find the average or the mean GPA. So we're going to type in equals average, open parenthesis, close parenthesis once we're done. There we go. Oops. All right. Now, one thing that you can do here, you don't have to, if you want to see a little bit more precision, you can go here and click on this link. It'll give you more decimals. You don't have to do that. That's up to you. So that's our mean. And then the next thing we need to do is find the t statistic, I believe, the t number and the p-value. So that means we need to run a hypothesis test. Now, I have heard from some people that had a hard time with just using functions for the normal, for the z, when we use the z-stat. One thing I'm going to show you how to do is how to use the data analysis tool pack to run a t-test to get the same results that you're seeing in Zybooks when you're asked to answer questions about those. The first thing we're going to do is create a dummy variable. You're just going to enter two zeros here. It does not matter. You don't need that. Just put 2 zeros there, and I'll show you in a minute why. Then we're going to go to data. Oops. Data analysis. We're going to scroll all the way down. Now, you see here t-test. We have paired, 2 sample, 2 sample, 2 sample. We are running a test with 1 sample where we're checking to see if the population mean is greater than 2.75. Now, when we start talking about hypothesis tests for 2 populations, that's when you have 2 populations and you're comparing the same statistics. So for example, I want to say that girls have a higher GPA than boys, or I want to test to see if girls have a higher GPA than boys, or I want to test to see if boys have a higher GPA than girls. Those are 2 different populations, girls and boys, and we're comparing the same statistic. We'll be talking about that down the road, but for now what we need to do is use this and kind of just do this little workaround in Excel to get those nice looking results. So pick this one that says 2 sample assuming unequal variances and click OK. You see here I had this filled out, so I'll just delete this just to show you guys what we need to do. So first what you need to do, variable 1, that's the actual variable. That's our GPA column. So let's go ahead and finish that. And then our variable 2, that's our little dummy variable. So let's go up to the top and just select those 2 cells. Again, we don't care about that. Here it has hypothesized mean difference. Again, we'll talk about that, the difference between these 2 when we talk about hypothesis tests for 2 samples. But for now, we're going to put in that 2.75. That's what we're testing to see if we're greater than 2.75. This labels option is only if you have a label up here and you selected it as part of your data range here. We don't have labels and it's not an important thing. So it's not something we use, so we don't need to worry about that. Alpha is automatically set at the default is 0.05. Since our alpha or significance level from the problem is 0.05, we don't need to change anything. Our output range, I'm just going to select right here. It's going to give us a nice little table. So we're going to click OK. See, nice little table. Now the one thing we don't need this because that's for that second variable that we don't care about. So I'm not going to worry. I'm just going to delete this for now so we're not looking at something confusing. And here it says 2 samples. So I'm just going to change this to t-test 1 sample just to clarify it for ourselves. And we have our nice little results table like you guys saw in SciBooks. So we're given our t-stat and our p-value. So let's go ahead. And again, we are dealing with a one-tailed test because we're testing to see if the mean GPA, the population mean, is greater than 2.75. If we were just testing to see if it was different from 2.75, that would be a two-tailed test, but we're not doing that. We're just doing a one-tailed test. All right, so let's come over here. So we already said that we're going to assume normality because it's basically normal. It's not perfect. Here we have our mean right here that we found. We're going to put that in 2.8278. T is this number right here, that 2.94. You can put in just 3 or 4, but we'll go ahead and put 2.943756. Our p-value is this 0.002. As I can tell you right now, that's very low. It's lower than our alpha. 0.02473. So since the p-value is less than the significance level 0.05, the null hypothesis is rejected. Remember, when p-value is less than alpha, we reject the null hypothesis. If p-value is greater than or equal to alpha, then we do not reject the null hypothesis. All right, so since the null hypothesis is rejected, we say sufficient evidence exists that the mean GPA is greater than 2.75. Let's check. Oh, nice little green check mark saying everything is correct. Again, if you have any questions about how to do this in Excel, let me know and I can go through it in more steps, but we'll keep going through the other parts of this problem to keep practicing. All right, a company that makes LED light bulbs claims that the bulbs have a lifetime of 11,000 hours. Quality control tests a random sample of 45 light bulbs to determine if the lifetime is less than 11,000 hours. So right now we're looking at a left-tailed test. 11,000 at a confidence level of 0.05. Use sheet 5 of the Excel file to create a histogram and calculate X bar, the test statistic, and the p-value. That should be significance level, not confidence level. Significance level of 0.05. Use sheet 5. Okay, so let's go ahead and look at sheet 5. And we're going to do the same thing that we just did. Let's make this bigger in theory. As you guys will see, MacBooks don't always agree with Microsoft products. All right, sheet 5. So we have these numbers here, which are closer to that 11,000 that we're looking at. So the first thing we're going to do is generate a histogram. The way we do that in my version is to go to data analysis, go up to histogram, click OK. All right, we're going to delete these and just go ahead and start from scratch to go through it every time. All right, let's go scroll down. All right, there we go. And we're going to click our output range. We're going to go up here and see what we've got. All right, let's look at this histogram. Oh, that looks a lot prettier than our last one. So I would definitely say that has a very good normal pattern to it. So the next thing we need to do is come up with our X bar, our sample mean. So we're going to say mean equals average, and we're going to select those 45 again. Let's see what we got. We got that nice number. I'm going to make it a little bit bigger just because I want to see a little more precision there. And then what we're going to do is the same thing we did before. We're going to create that little dummy variable with the 2 zeros. I'm going to go over to data analysis, and we're going to scroll down. We're going to pick that t-test 2 sample unequal variances. And we're going to change all this from our last thing. Okay. So our variable 1 range is going to be that to 45. Our variable 2 is just going to be those 2 little zeros, the dummy variables. Again, we don't have labels here. Our hypothesized mean difference, I believe it was 11,000. Let's see. Yes, 11,000. So we're going to leave that there, and then our output range, we're going to select where we want our table to go. I'm going to put it right there. All right, click OK. We're going to delete that little dummy column because we don't care about that second variable. We're going to change this to t-test1 sample. Make this just a little bigger so we can see everything. Again, okay, so we have got our t-stat and our p-value. So let's take a look over here. Make this a little smaller. Oops. All right, there we go. Oops, sorry, we scrolled up a little bit. All right, so from the histogram, can normality be assumed? Again, we kind of said here that it looked really nice. So we're going to say yes. Our X bar is right here. That's that 10521. So we're going to, oops, let's make sure that we can actually see it. All right, so we have 10521.2914. Our test statistic right here. Now, what were we testing again? We were testing to see if the lifetime is less than 11,000 hours. So let's type in negative 3.762661. And then our p-value is right there, is 0.000, oops, 30247. All right, our p-value is very low. So we already know right off the bat that we're rejecting our null hypothesis. So the p-value is less than the significance level of 0.05. The null hypothesis is rejected, and we would say sufficient evidence exists that the mean lifetime is less than 11,000 hours. Let's check. Nice little green check mark. Let's go on to the third section. Here, we're going to be using the same spreadsheet, but looking at sheet 9. Just right off the bat, I can tell you that. A power company is installing utility poles that are supposed to have a height of 40 feet. The foreman checks a random sample of 60 poles to determine if the mean height is 40 feet at a significance level of 0.05. Use sheet 9 of the Excel file to create a histogram and calculate X bar, the test statistic, and the p-value. So we're doing the same stuff, but now we're looking at sheet 9. So let's go ahead, open up sheet 9. We're going to first do the histogram. So we're going to go to Data Analysis Pack. We're going to scroll up to Histogram. Click OK. We're going to select all of these values here. And on our output, we can just put there in D2. That's fine. Remember to select that chart output because it won't be done automatically. Click OK. Let's look at this histogram. That's not too bad. Again, it's a little rough pattern, but it's not too bad. It's overall got that kind of bell curve to it. So the next thing we're going to do is find our mean. We're going to say mean and equals average, open parenthesis. Oops, let's make sure we get that first one. And then that's our mean. Now, we're going to create our little dummy variable. We're going to go to data analysis. We're going to scroll down to that t-test 2 sample assuming unequal variances. All right, we're going to clear all that. We can leave because that's the same one. And we'll have to double check that. Okay, so first let's select our there we go. And then what was our hypothesized mean, or what are we looking at to test? Let's see here. It was 40 feet. So we're testing to see if the mean height is 40 feet. Okay. So we're going to type in 40. Oops, I must have missed something. Oh, output range. There we go. My bad. All right, now there we go. So let's go ahead and delete this one. Edit, delete. And let's go ahead and put in our value. So we already said it's normal. Our mean here is right here. That's 37.20219. Our t-stat is going to be for a two-tailed test because we're looking at a two-tailed test. So that's going to be 1.671093, and our p-value is 0.0234